Right, we're going to continue with lecture 3. We're going to cover exceptions, runtime errors, try else, creating a function to get an integer, parse statement, and summing up. Exceptions. Exceptions are things that go wrong within our coding. Exceptions are problems that arise while your program is running. Now, text editor, type code hello, part required to do file, type as follows with intentional errors included. So let's create a new file here. A Python file called hello. And intentionally, we're going to write this and leave out the comment. So the code's over here. And let's now go back to our run the file. And it gives it error, syntax error. Notice that we intentionally left out the quotation marks at the end over here. Running Python hello in the terminal produces an error. The interpreter reports a syntax error. Syntax error, there it is. Syntax errors generally mean you should double check that you typed your code correctly. You can learn more about this in Python's documentation, errors and exceptions. Runtime errors. So runtime errors refer to those created by unexpected behavior within your code. For example, perhaps you intended for a user to input a number, but they input a character instead. Your program may throw an error because of this unexpected input from the user. In your terminal window, you can write the following. Or this code says number.py. So let's create another file called number py, and let's input this. Save it, save this file, and we put the code in. Notice that by including the if string, we will tell Python to interpolate what is in the curly braces as a value of x. Further testing out your code, you can imagine how one could easily type in a string or character instead of a number. Ever still, a user could type nothing at all, simply hitting the enter key. So let's now run our number py. That's what's x, so let's put a character. I'll first put number to test the programs like 5 or fine. Let's run it again. Let's put a character, letter A. And it says it's invalid literal for int with base 10a. And this speaks to a runtime error. We're expecting a number and the user input a letter. So we get a value error or runtime error saying invalid literal, we're expecting a interliteral. As programs, we should be defensive to ensure that our users are entering what we expect. If we run this program, type cat, we can run cat as well. We'll see value error, invalid literal for int with base 10 cat. In other words, the int function cannot convert the text cat into a number. An effective strategy to fix this potential error would be to create error handling to ensure the user behaves as we intend. You can learn more about this, again, under errors and exceptions. Now, how do you do error handling? We use try and except. First start with try. In Python, try and except are ways of testing out user input before something goes wrong. Modify code as follows. So same code, but now we have just added the try statement, indented the code, and have accept value error in it as well. So for example, if we run this code again, say 50, it's all fine. Run it again, say cat. It catches the exception, it catches this runtime error, which is better way to handle errors instead of having effectively the program crash, because this is effectively will crash a program if you see this red error popping up. So notice how we run the code, inputting 50, it will be accepted. However, typing cat will produce an error visible to the user, and the program doesn't crash or stop, which is also important. instructing them with the input was not accepted. This is still not the best way to implement this code. Notice that we're trying to do 2 lines of code. For best practice, we should only try the fewest lines of code possible that we are concerned could fail. Adjust your code as follows. So a slight improvement to our code. Run it again. This should work. Run it again, shift enter, cat. Notice this was a problem. While this accomplishes our goal of trying as few lines as possible, we now face a new error. We face a name error where X is not defined. Look at this code and consider why X is not defined in some cases. Let's have a look at the code. So I was trying to print X. X is true in this code block. If try is true, then it's fine. But here it's not. And this is an exception because cat was input. It's going to run this code and X is not defined. So it cannot run this. Indeed, if you examine the order of the operation X input, working right to left, it could take incorrectly inputting character and attempt to assign it as integer. This fails. Assignment of X never occurs. Therefore, there's no X to print in the final line of code. The else statement. It turns out there is another way to implement try that could catch errors of this nature. Just your code as follows. So it's very similar. Now we're just adding an else statement. Notice that if no exception occurs, it will run the block of code with an else. Running a Python number and supplying 50, you'll notice the results will be printed. Trying again this time, supplying cat, you'll notice that the programmer catches the error correctly. Try it again. 50, looks all fine. Try it again, type cat, and it catches it correctly. Considering improving our code, notice that we are being a bit rude to our user. If our user does not cooperate, we currently simply end our program. Consider how we can use a loop to prompt the user for X if they don't prompt again. So just adding a while loop into our code. We've added a while loop, we've added a break as well, and printed the value. So this is to catch a case if the user doesn't input anything. Notice that while true will loop forever. If the user succeeds in supplying the correct input, we can break from the loop and then print the output. Our user that inputs something incorrectly will be asked to input again. That's the code, this is a bit cleaner to do. So if say 50, it'll work fine. Say cat, apple, dog, 5. There we go. So I kept on asking until I gave the correct answer. Creating a function to get an integer. Surely there are many times where we would want to get an integer from a user. Modify your code as follows. So now we're just writing a function for the same code to make it a bit more user-friendly. So we have our main function. We create a function that says getInt, which is what it does, and it should output the same thing. Notice that we are manifesting many great properties. First, we have abstracted away the ability to get an integer. Now this whole program boils down to the first 3 lines of the program. Even still, we can improve this program further. Consider what else you can do to improve the program. Modify your code as follows. So this stays the same. While true, X, except print. Okay, so now we're returning. This is the small change. The return just moves up to here. So I'm not going to copy this code. I see the update, which is a bit cleaner way to run the code. Just to check if all runs fine again. Say 50 works. That's okay. Cat, apple, and 5. So it worked all the same before. Again, try this code out yourself. Pause this video and try it yourself. Make sure you get the same inputs and outputs. Notice that the return will not only break your loop, it will also return a value, which is more useful. Some people may argue you could do the following as well. So these lines of code look the same. While true, try. Okay, this is but even cleaner. Again, it's more abstracting the process. Through abstraction, you kind of maybe get a bit less understanding of how the code works. So these are just more and more ways to abstract the code. You didn't have to do these improvements. As you can see, they're all the same thing. But this is effectively what it's doing. So now we take away the else statement and just return that it's true. Should do the same thing, but run it. 50 is fine. And again, cat, apple, 5, fine. So again, more and more abstraction makes the code cleaner, but maybe gives you less understanding of what the code does. So notice that this does the same thing. This does the same thing as a previous iteration of code, simply with fewer lines, that's all. The pass statement. So we can make it such that our code does not warn our user, but simply re-asks them our prompting question by modifying the code as follows. So this stays the same. Well, same. This is the same. An exception, we just put the past built-in function, and this won't inform the user that what the input is correct. It'll just loop until you give the correct answer. Notice that our code will still function, but will not repeatedly inform the user. Okay, pass actually mistaken there. Pass will just exit the while loop. Some cases you want to be very clear to the user what error is being produced. Other times you might decide you might simply want to ask him for input again. A finer refinement could improve the implementation of getInt function. So right now, notice we're relying on currently on a system that X's both in the main and getInt functions. We probably want to pass in a prompt that the user sees when asked for input. Modify the code as follows. So this stays. This is different. Input is different over here. So this update over here, prompt. So we're just now adding input to the function, prompt. And then returning int, input, and prompt. So again, abstracting further, making it a bit cleaner. Again, you don't have to do this. You can use the first example that worked, the first few. Just make sure you understand how it works. Further abstracting your code, or by that using a few lines of code, might look cleaner and better, but functionally you have to also understand how it works. And maybe writing code that's more verbose, has more lines of code, might be better for you to understand, especially if you're a beginner. But this will still work in the end. So you can learn more about the Python's documentation of pass if you want. And finally, summing up, errors are inevitable in your code. However, you have an opportunity to use what was learned today to help you prevent these errors. Important. It's actually learn about exceptions, value errors, runtime errors, try, else, and pass. Great. Thank you very much. Hopefully you learned something. Until next